Good morning, everyone. I'm Azvern Dias, an S.E Computer Student, and today's first session is a roadmap to development, a beginner's guide. But it's not just a roadmap on development, we're going to talk a lot more, and I'll let you know in the next slide. So, the entire group session is called Dive into Dev, where the first session is today, which is an offline talk, roadmap to development, that is hosted by me, and the second one is Introduction to Open Source and Hacktoberfest, which is hosted by Grishma tomorrow. It's an online workshop and it's going to be an interactive one where you all will be able to do some things together with. So about me, I'm Azvern Dias, S.E Computer, as I told you. I have 1.5 years of game development in Unity, 1.5 years of Flutter app and web dev, and 6 months of bot development. And the goal of today's session is one, to make technical jargon of development simplified for you all, clear some concepts and clear some misconceptions regarding development, and of course the roadmap to development. Yeah, so this is the opening image, a chicken and an egg. So why is there a chicken and an egg? What's the difference between a chicken and an egg in terms of food? They both come from the same species. A chicken gives an egg gives a chicken. So what's exactly the difference? We both know it, but sometimes it may be difficult to give it in terms of food in words, right? And that is what the difference between software engineering and software development. There are major differences between software engineering and software development. Even though they are related, there are a lot of differences. For example, the thing that you need to know for software engineering is competitive programming and data structure and algorithm, which forms the core. Secondly, in software development, it's obviously developing applications. Software engineering is more of a team activity where you have to work a lot with a team of developers, a team of engineers. You have to work with your company officials, the HR, the whole management and everything. But software development is mostly solo, whether you're freelancing or whether you're working in a team. Software engineering is not freelanceable. You have to get a job. It's a big company, MNC or whatever. While software development is easily freelanceable even from your first years onwards. A software engineer is very much involved in the entire process, right from the start of the project, from the idea to the execution, while the software developer may just work with the application itself. And at the end, a software engineer solves issues on a larger scale, while a software developer is just solving issues on a specific scale. So to sum it up, a software developer does exactly what a software engineer does, but on a smaller scale. So to begin with development, I'm going to use Netflix as an example to demonstrate what is front-end, back-end, and development in general. So when you use Netflix, how many of you have used Netflix? Or at least some form of media streaming platform. So what do you use Netflix for? When you start, what does Netflix do in the app? You log in, right? This is first thing, log in, sign up. Then it slowly gets better, recommending what titles you want to watch. If you mostly watch action movies, it's going to show action. It doesn't do it automatically, right? Because it can't read your mind. But over time, as you watch more, it's going to figure out that. The next thing, it obviously has to show the movie somewhere else. How can it access the movies and send it to your devices? It has to be able to search all the 6,000 plus titles on Netflix and then send it to your device when you type it in the search box. Then send the media to your device to be played. Manage payment system, the normal things at the end. So here's a kind of basic flowchart on front end and back end in terms of Netflix. So if you see over here at the start, that's the front end, which is Netflix website app, and the back end is the server. The Netflix website or the app will have a sign up. So when you sign up, you create an account. That account data will go and get stored in the server, in the store accounts over there. Then when you want to log in, say you want to install the app and you install it again, you enter your details. It's going to take the data from the accounts that are stored over here and then take it and log in. Right? And then the next thing would be to, suppose you are in India, there's some content that's available in India but not available in America, etc. So it takes the location and other things from your device IP address or the location Google Maps which is on your phone, sends it to the server so that Netflix knows, okay, user 123 stays in India and so and so. So it takes that and then it creates a personalized profile which is based on your liking, the location info and everything basically that's linked to your account. So you can see the flowchart, the store accounts is directly linked to this algorithm. And then when you the recommended movies that you may like, is based on this algorithm over here because it's based on your liking. So everything you can see over here is interconnected. Even the search system is basically in the server. So when you type, the search algorithm is executed on the server and it just sends the data of all the lists based on the search parameter that you have given. And the rest is of course play media, and the adverts are being sent to play media. By the way, advertisements also are tailored to your specific needs. So basically, if you live in India, you'll mostly get Indian ads because again, that advert part is linked to your information. Oh yeah, and one more thing, server is not one central server for everyone all across the world. Since there's also a lot of time delay, suppose you live in India, if you want the movie to be played from America, it's going to take a long time for the data to be transferred over the internet to your device. So there are multiple servers all across the world. So if you're an Indian person, there's a Mumbai server, and all the movies are stored on the Mumbai server, and they are taken to your PC. So that's also linked to this, your location, etc., and it's going to automatically choose the closest server to you. So this is basically the difference between front end and back end. A lot of people don't know the difference, but basically this is it. The front end is related to the thing that you have, the client side, what you see, what happens to you when you use the app. That's front end. And back end is the server, the background work. So basically, in terms of movie making, the actor is the front end, and the back end is the director, the producer, and the editor. So what is front end development? This is a generic definition. It refers to the area of development that focuses on what users see. It transforms the code built by back end developers into a graphical interface, making sure data is presented yada yada. So what does he actually do? Well, first of all, if you're working with a team, there's going to be someone who's going to design something in, let's say, Photoshop or something. There's a tool called Figma. He's going to design an app which is not related to code at all. What is your job as a front-end engineer or a developer? To convert that design using code and make it run on websites or apps. That's what a front-end person does. Make sure that the design works on all targeted devices. If you have used Netflix, you'll know obviously. On the app it looks different, on the website it looks different. There are different screen sizes based on that the font changes, how big the font is. A bigger screen obviously means bigger font, etc. So that is done by the front-end person. Safely send, receive data, etc. from servers. When you log in, your password and email is not sent as normal text to the servers. It is encrypted and sent in an unreadable format by other people that is secured, so that your data can't be accessed by people who are in the middle waiting to catch the data. So that is the job of the front-end person, to make sure that the data is sent securely. Make the best use of user device location. That's what I mentioned before, right? Because the back-end person does not have access to your front-end stuff like your mobile location, your camera, everything. For example, Instagram, it needs your camera. The back-end of Instagram cannot use your camera, right? The front-end person needs to do it. So the Instagram developer on the front end will use the camera, etc., and make the app, then we send photos to Instagram server, etc. Now backend. Backend development means working on server-side software. It focuses on everything you can't see on the website. It ensures that the website performs correctly, and the main focus is database, backend logic, application programming interfaces, which I'll talk about later, the architecture and the servers. So mainly the logic, the database is handled by the backend developer. So most of logic and heavy work, connect the storage to front end, develop back end. It works with all front end platforms, as I mentioned, the app and so basically when you have Instagram, right? Instagram has a website and an app. The app is a different front end technology and the website is a different front end technology. But the back end is the same. This ensures that what you see on the app, the same photos you'll see on the website when you open it. So this maintains continuity between everything. So basically, a company, if it wants to make an app and a website, it needs to handle only one back-end team, but two front-end teams, because they both are separate things. Time optimized code, this is a very important thing. As I mentioned about the servers, even a delay of 0.5 seconds is known to drop the user inflow by 70%, which means that if a user clicks on your website and it takes 0.5 seconds for the thing to load, it's going to drop your user inflow by 70%. That involves the back-end person, where the code that he runs has to be optimized so that everything is done fast and instantly. Because we live in a world where everything is connected and everything has to be done fast. So a lot of work on the time optimization is done by the back-end person. Not to say that front-end does not do it, but most of the work has to be done by the back-end person. Scalable software. An app that may work for 10 people won't work for 1,000 or 1,000,000 people. For example, if a database has only space of 100 people, and suddenly the app became popular, and you have like 100,000 people, the server won't be able to handle the load. There are hundreds of people asking for photos, uploading, downloading photos. A server has RAM like our computers only, and they won't be able to handle. So the person needs to know and figure out how many people are going to be there. How to scale it. Suppose there are 10 people now. If there are 100 people, will he have to uninstall the entire backend and write the backend code again? No. So he has to first only optimize the code and make it scalable. That's the meaning of scalable development. And this I'll speak about later, but it writes code to that facilitates communication to and from front end. So basically, there should be some sort of communication between the front and back end, right? So that communication protocol is developed by the back end person, not the front end. So as you can see right now, most of the work is done by back end. So it's really preferred that people know a lot of back end do along with front end, even though front end is slightly easier than back end. Yeah, so a lot of people say, what is the difference between back end versus front end in terms of visualization? So yeah. So if this was front end, this is the back end. When everything, the dirty work, the thing that you can't see, doesn't look clean, is done in the back end. But at the end, the user only sees this, and that's what matters to the company, that's what matters to the client, that's what matters to the developers. Frameworks. This is a term that not many people really understand. So framework, as the name suggests, is simply a product of software that developers use. And it helps because it supports and guides you while you're developing your code. For example, this is a function to sort an array. People, how many are non-CS over here? Who have not done C++? Okay, not bad. So basically, if this is an array of numbers, right now it's 1 to 3, for example, it was 3 to 1 or something. This entire code only job is to make the number into sorted ascending order, 1 to 3, and give it as an output. And here is a thing developed with a library that does it in just 3 lines. So you can see the difference. Here it's so big and you have to do it manually everything. But here, since the program knows that, okay, this user will eventually need to sort an array, so there are things that are inbuilt. So that's what a framework does basically. It does a lot of inbuilt things that help you as you code. For example, if you're making an app, what's in an app on the top? An app bar. Then there's a side drawer at the end of Play Store where there are a lot of things. There's a button on the right maybe. So these are things that are already inbuilt. You know that you have to make a button for an app. So basically, a framework does the things inbuilt for you. You just have to call that function or whatever and it does the work for you. And you have to edit the stuff. So that's what a framework is. Here's another example. This is how to make as I told you, the app bar in React Native. This is a framework for Android. And this is just the code to make the app bar, which is the top heading of an Android app. So you can see how short it is. And now, how do you do it in native Java, which is the basics of app development? First you write this, which is an XML file. Then you need to write an activity XML file for the same header. And then you need to write this entire Java code just for the app bar. So you can see the amount of difference in just making an app bar for an Android app. So this is where frameworks help you. The things that are inbuilt, the things that normally are there by default in an app or a website, are there inbuilt into the language. You just have to call that function as you saw in the previous image, and it does it for you. APIs. So what's an API? An API is a way for two or more computer programs to communicate with each other. It's a software interface offering service to other pieces of software. So basically, as I mentioned before, the front end and back end have to communicate, right? Whether it's transferring information, like the login information, or maybe it's Instagram, you're sending photos, receiving photos from the server. So basically what you do is you create something called an API. An API is a part of code which the back-end person can access as well as the front-end person. And you send your information through that API code, which then sends it over the internet to the back-end person and to and fro and so on. In simple words, an API is like a postman. If the front end is the sender of an email, the receiver can be the back end. The postman just transfers, and the information is stored in the envelope. So the envelope is your API. Okay, so that's just basically what an API is. Here's an example of an API. So it's not really readable. Okay, so I don't think it's really readable, but this is a API that gives you random codes. The thing that's written on top is, if the plan doesn't work, change the plan, but never the code. If I refresh this page, that smiles at us all. All we can do is smile back. So basically this API is developed by a backend developer. It's hosted by a company on their own servers. So you as a front-end person will just call this API in your code using this link. It's going to send the data in the form of a string, in form of a text to you in your front-end application. What you do with that, with the string, you display it to the user in the form of a card maybe, with a picture at the side of the author or some code picture. And so you basically have an app that can post codes. Every day, maybe the user presses a button for refresh, it gives them a new code. So basically they're using just this one link, you can make an app that gives you codes every day in the morning, daily motivational codes app or something like that. And you have it. So this is how you call backend. It's just a link. You take that link, you get information from it, you transfer that information you transform that information in a way that can be used by your front-end person. Of course, this is just a basic API. It's not something called a RESTful API, which is out of the scope of this. So basically, this API is just for information passing. There's no authentication or anything. But in form of Instagram, etc., as I told you, there should be authentication. Is this a legit Instagram app that is sending me the photos? Is this a legit Instagram app that's making an account, etc.? For that, you need to use something called REST APIs. That's what normally people use for developing, etc. And over there, you can make your own APIs that's done by the backend. Over here, as a front-end person, if you just want to do a basic website, there are a lot of free APIs like this. You search for free APIs, you just get the link, you put it in your program, you learn how to use it, and that's it. You don't have to worry about authentication or anything like that. Yeah, so it's a vessel for communication between backend and frontend. Backend developer make the APIs, and front-end developer calls the APIs. Okay, now we come to the roadmap session of the development. What are the categories of software development? Web dev. Yeah, are there any questions so far based on what I've spoken before? You're free to shoot. Anyone? It can be anything. No. So yeah, so the first category is web dev, web dev, which are two different things that I'm going to. Yeah.
Is it the same thing with YouTube and all?
Yeah, so YouTube also uses front end and back end. There's a server that whenever you upload a video, the video goes to the back end and gets stored on servers. There are lots of storage spaces, more than petabytes of storage, and the videos are stored over there. So when you play a video, what it does is first it checks, is there a server in India, which is Bombay, which hosts most of the YouTube servers, and then it plays a video from there. It calls a video from there, it plays a video, and then till now, for example, I told you there's time delay, right? So there's a time delay even if the video is in YouTube in India, because your internet may be slow, there may be some issue with the server. So what the front-end person does is it creates a loading logo, and that is why you see the loading logo. The loading logo will play until the video is got from YouTube servers, and then it plays the video. That's how it's done. And how do you get the video from backend? When you click on a video, it calls an API. The API has a YouTube code that you can see after youtube.com/some code. So that code is sent to the YouTube servers. Over there, it's going to check, okay, this video has this code. I'm going to send this video back to the user. And then it plays on the server, and that's how you get it. Along with the YouTube ID, you get also the data like the comments, etc., and that gets played. So that's how it's done with YouTube. So web dev and web dev, I'm going to talk about this later, but they two are completely different things when it comes to getting jobs, etc., and when you tell people what you do. App dev is, everyone knows how to you make apps, Android or iOS, they come on app developers. Third is game dev. This is probably the most fun and entertaining one of all three of them. We'll speak about it later. Rough roadmap for any of this is basically learn your basic code in C, C++, pay attention to your classes. C, C++ is really important. For beginners who haven't done coding, it really sets the foundation. It's a very low-level language. You learn a lot about not just coding in general, but how a computer works, the integers, everything, etc. So for development, I would really recommend do C, C++. Second is, of course, choose one of the three. Then you start learning and, of course, creating projects. That's the only way you can ever get better at what you do. Okay, here's I'm going to show you all two links, and this is link one. So it's Azvern News, okay? And this internet is a bit slow. This is Flipkart. What's the difference between Flipkart and Azvern News in terms of a website? Can anyone tell me here? Anyone? Even if it's you are not sure, anyone? So
Azvern is only selling news.
related to a technical term, if you can. Yeah, that's one good point. So basically, if you notice, Flipkart has a lot more interactions. You log in, you sign up, here you can sort, you can filter, there are different categories, you can select the price, you can select EMI, and to log in you can pay an order. Basically, compare that to Azvern where you just read. There are different tabs, of course, you can interact. But what they do is just display information. You cannot change the contents whatsoever. That's the difference. The keyword here is interaction. The difference between a website and a web app is interactivity. A web app is a software, but a website is just a static site. The difference between a website and a web app is also that a website is static and a web app is dynamic. Because you make changes to Flipkart, right? When you sort by categories, the same page is loaded but with different things. For example, if there's laptops, the same page is used, but except when you go to mobiles, instead of laptop pictures, there are mobile phone pictures. So that's the difference between a web app and a website. A website contains static content that cannot be changed. It's simple, non-interactive at the most, and it's not pre-compiled. Link B, which was the web app, Flipkart, is dynamic content. It changes every time depending on the necessity of the person that's using it. It is complex and interactive. It's not a simple HTML, CSS website when you talk about Flipkart. But Azvern could be written in HTML, CSS, and it wouldn't matter. Secondly, and the final point is, it's pre-compiled and then sent to the browser. Basically, when you install an app, it's compiling the app and then sending it to your phone. That's what happens when you load a website like Flipkart and etc. That is why it takes slightly longer to load compared to Azvern, etc. Because it has to compile the app, compile the software, then send it to your device, etc. So web dev. Web application development is the creation of application programs. They reside on servers, as I mentioned about Netflix, etc. A web application needs to be downloaded and is instead accessed through a network. It's not downloaded like your Play Store, iOS, or your Windows application, your Mac or Linux, etc. It's always run on the browser. You're not downloading anything. Of course, you're downloading through the browser, but it's not stored on your PC anywhere. And then an end user can access a web application through a web browser, and of course, Chrome, Firefox, etc. So what's the roadmap to a web app dev? To be a web app dev, of course, you need to know the basics, which is web dev itself, HTML, CSS, JS, which comes over there. Secondly, you create projects with HTML, CSS, JS, so that you can make at least static websites like Azvern. Then you learn a framework, which I mentioned earlier, how framework works. They do the stuff for you, because as you make web apps, it's really difficult to do it in HTML, CSS, JS. As I mentioned with the Java code, it like just keeps growing and growing, and you'll be like with 5,000 lines of codes, and then oh my god, and you want to debug it, you're going to bang your head on the PC. After you learn the framework, rinse and repeat, create projects again. Once you do that, you'll be able to you can call yourself a web app developer once you can create projects using a framework. So this is basically what HTML, CSS, and JS is for people who haven't done web dev. So HTML is basically the basic structure of the code. For example, if I make a website like Azvern, only one paragraph, what's the heading, right? That comes on the HTML. What is the font, the color of the font, the design of the font? Is there a yellow box around it? That comes with the CS, which is the skin, how good the thing looks. And then basically JavaScript is the functioning. For example, in terms of web app dev, the login part and all is done in some form of JavaScript code. For example, JavaScript is written, basically the logic. This is the muscle system, the neuron system, etc. basically over here. And that is used to basically handle the logic part of it. Using these three, you can make basic web apps, but I would recommend that you just make websites. and then you use a framework for web apps. So this is how HTML, CSS, and JS works. JS, by the way, is JavaScript. Frameworks, as I mentioned here, these are the top 3 frameworks for front-end web development. The first one is React.js. It was developed by Facebook some years back, and it's also used by Facebook and Netflix. That's the logo for React.js, and that's what people mostly use right now for web development. It's the most popular one among the top 3 here. And it's called React.js because, as I mentioned, it's a framework that is based on the language, and you do stuff using that language. So it's React in JavaScript. So you're basically writing JavaScript, but it's a modified version that has a lot of inbuilt stuff. So use that, and you can develop web apps faster. Then comes AngularJS, which is again a JavaScript framework using PayPal and Microsoft Office. Vue.js, which is used by Nintendo and Chess.com. These 3 are the main 3 popular used by major companies so far at the moment. There are a lot more, there are like thousands of them, but these 3 are the most popular. I would recommend you to go with React.js because there's a lot of help online, YouTube, etc. And it's really helpful because Stack Overflow, etc. has a lot of resources regarding React.js. What about the cash money? How much do you earn as a web app developer? If you're a beginner freelancer as a web app developer, you can earn right from 8,000 to 16,000 just as a beginner. As you advance further, you spend some more years, you create your portfolio, you make more websites, etc. It's going to increase by a lot. Freelancing is a really good opportunity for web developers because it's better than getting a job in terms of web development if you're good at what you do and you're passionate about it. Second thing is a beginner job of a web app developer, provided you have a good portfolio, provided you're good at what you do, you know other things, 3 lakhs to 5 lakhs per annum is for a beginner person. It can go up to 12 lakhs if you have a 10-year experience in web development, and people have got even 17 and 20 lakh packages if you are a web app developer. So that was just about web development. If you have any questions?
Do you need to know the base layers to learn the JavaScript?
Yeah, just as I mentioned the framework, the roadmap, you need to know your HTML, CSS, and JS because can you create an app without knowing how to code? So that's about it. You need to know your basics of HTML, CSS, and JS because they are the foundations on which the other frameworks are built. You will be using a bit of HTML and CSS when you're doing web apps too, using the frameworks. But it's at the basic, but that helps you develop the logic that you need to create the web applications, etc. You need to know the basics, and that is why we use the 7 standard maths, so you have 12 standard, and so on. Because what you learn at the lower level is the foundations for what you do later on. And that's very important when it comes to software development. Otherwise, trust me, you're going to get really lost if you start directly with the framework. Yeah. Anything else? Any questions regarding web development? Am I going a bit too fast? Any questions? So mobile development. This is a really nice one compared to web dev, in my opinion, because I do mobile dev, so obviously I like it better. Mobile app development is the act or process by which a mobile app is developed, personal digital assistants, etc., etc. The basic thing is they run on mobile devices that are not a PC or a desktop. It's a tablet or a mobile. Whether it's Android or iOS, doesn't matter, it comes on the mobile level. But because this is a beginner session, I'm only going to be speaking about Android dev and not iOS dev. Oh yeah, mobile dev is done in Java. So a lot of people ask me, is Java different from JavaScript or is JavaScript related? So here's the answer. Java is to JavaScript what car is to carpet. They have no relation, it's only the name that is similar. And the backstory behind this is actually funny. So the developer of JavaScript, which developed many years after Java, wanted his language to be popular. So he decided to name it JavaScript so that it gets popular. There's no relation to Java and JavaScript. That's the actual true story. So yeah, that's about it. Rough roadmap to mobile level. Learn Java. Just as I told you, you need to know HTML, CSS, JS for web. Java is the basics of app development. Android Studio is the application in which you'll be running your apps, you'll be compiling and debugging, etc. It has an Android emulator, so if you don't have a mobile device, you can run a virtual mobile on your desktop or your laptop, and then run apps, create apps, etc. It has a lot of tools that help you. Basically, it's a helper to your framework, kind of. It has a lot of tools that can be used that otherwise on like a normal text file, if you do, it's going to take a year or more than a year. So basically, learn Android Studio. It's by Google, it's developed by Google, it's handled by Google, and it's the official IDE to make Android apps. OOPS and DSA. For second year, I think you all know what OOPS and DSA is. But for first years, OOPS is object-oriented programming and data structures algorithms is DSA. DSA is C, it's taught in C, and it helps you with how data is stored, etc., how data can be accessed, different forms of data, etc., something of that sort. And OOPS is object-oriented programming structure, which is a form of programming using something called classes and objects, which first years may not know if you are not CS students 11, 12. But you only learn it over the course of your first year and second year, and I would highly recommend you all to pay attention to those classes, regardless of what you're doing. Pay attention to DSA and OOPS. Yeah. Then build apps. Once you know your DSA, OOPS, you know Java, you know Android Studio, make apps. Same with web development, as I told you learn the basics, you make your web apps. You do that, then you learn a framework. It's the same thing, rinse and repeat. You build apps. Android Studio it looks something like this. So here's your virtual device that you get on your PC. In case you don't have a phone, it's directly connected to Android Studio and you can run it like this. Here you run the code and there you get the files. It's just like a normal IDE, if you can see here. The files are stored on the left. You can run your code using the play button, which is a bit high for me. But you can see it over there. And this is how you run your app. So when you make a code, you save it, it gets reflected over here. And this is how you code Android app in Android Studio. What are the mobile development frameworks? There are not many popular mobile dev frameworks. The most popular one is React Native. Again, it is not the same as React.js, but it is developed by Facebook itself, and it's the same company that made React, the same team. But they're totally not related, just how Java is not related to JavaScript. And React Native is used by a lot of apps, including Instagram, Facebook app, and Tesla. And this is Flutter. This is a framework that I work in, and it's a relatively new one that came a few years back. And it's used by GPay currently and a few other apps, but it's not optimized that good. It's made for good UI designs, but it's not really it's not fast compared to React Native. So as a beginner, get into Java, then get into React Native is what my opinion is in regards to frameworks. This is a Flutter logo, that's a React Native, it's the same logo. Again, what about the cash money? As a freelancer, you can start from 6,000, that's a basic, maybe a calculator app if someone wants for some reason. You can get, especially since you're a beginner, they're going to pay you less, obviously. And then you can go up to 20K as a beginner. 6,000 to 20,000 is the range of a beginner app developer as a freelancer. And in terms of jobs, of course, 3 lakhs to 14 lakhs as a beginner again. Beginner to intermediate. That is, if you know a framework, you have some projects, etc. And of course, it can go up to 20, 25, depends on how good you are, how many years you are in the field, etc. How many projects on your portfolio, and a lot of other things. Yeah, so any questions about mobile development?
What about Kotlin?
Sorry?
What about Kotlin?
Oh yeah, so Kotlin is another language developed by Google to facilitate easier app development. I didn't want to mention it because I thought it would be outside the scope of this, but since he mentioned. So basically Kotlin was developed by Google. It was made specifically to just develop Android apps. Meanwhile, Java is a versatile language. You can do web apps also in some form. You can do Windows applications. You can run server-side code. Minecraft, if you all have played, is written in Java. A lot of things are written in Java, and it was at its peak, it was there on every mobile application. If you all remember, there was a Java teacup on old phones when you should run the Snake game, etc. You're too young for that. So you all know this. So yeah, so basically Java was the peak, and hence it was used by all Android phones, etc. to develop their apps, etc. And it was the most popular at that time. But slowly, as new frameworks came like React Native, etc., slowly declining. And so to help, okay, Java, there's one more detriment I would say, that Java you have to write a lot of code, as you saw previously, right? Compared to Kotlin, where you don't have to write that much code in Kotlin. But the thing is, if you know Java, you can do anything. But if you know Kotlin, you can do only Android. So if you lose your job suppose app development is banned for some reason, you have lost, you have no other job, you're homeless, you have no job. If you learn Java, you can do something else. You can even write simple programs, you can make a calculator. You can do anything with Java because the main tagline of Java when it released was write once, run anywhere. So you write once on a compiler, you can run it on a mobile, you can run it on a server, you can run it on a PC, etc. And that is why I would recommend learning Java because there are a lot more applications other than mobile dev. But suppose for some reason you know your future, you know you're going to only do app dev, of course Kotlin is the best thing for you because it's easier to implement, etc. So that's it. Also the apps are smaller in size compared to Java because as you know, you have to write less code, so smaller apps. So that's the difference between Java and Kotlin. Therefore I would recommend learn Java, a lot more users. Anything else?
How to start doing any projects?
I'll come to that later. I have a slide. Game development. This is the best and the most fun, the most entertaining game development. Of course, it has its detriments, but this is the best thing because game development is not just coding. Coding is just one subcategory of game development. You have to deal with the audio, the video, how the game looks, the 2D art, the 3D art, the game engine, what are the physics of the game. Maybe your player is on the moon, so you have to deal with moon physics. Your player is on the earth, so you have to deal with earth physics. A lot of things that come into game development and makes it really fun if you're doing it as a hobby. So yeah, here I mentioned user interface, the game logic, audio, the story, you can tell stories through your games. It's really a fun thing to get into. What's a rough roadmap to game development? Download Unity. Unity is a game engine that is used for game development. It's mostly used for 2D games, but there are a lot of 3D games too. Then learn your OOPS. OOPS is very important in terms of game development more than anything because, for example, second year students know about class and object, right? Second year onwards, you need to use object oriented in terms of a player class, an enemy class, and then there's going to be something called a health class, which is common to both the player and the enemy, right? So that is why object-oriented programming is very important in terms of game development. You need to know that thoroughly. Learn how to create player movement, that is how the player moves in terms of your input, etc. The speed of the player, that's variable, that comes under coding, which I won't get into because this is just an overview of the roadmap. Then the game mechanics. Can a person take a health kit? Does the health increase by 10% or does it go up to max? All the game mechanics regarding shooting, moving, etc. comes under game mechanics. The last thing would be level design and audio design. Is your game an open world like GTA 5 or something like that? Or is it just a platformer like Super Mario? That comes under level design. Audio design is like Super Mario audio is like very clunky and 8-bit sound, the olden generations of funny sounds, compared to realism sounds like COD, Valorant, etc. where the sounds are more realistic. So that comes under sound design. So all these things are done by the game developer. So unlike the mobile dev and app dev and web dev, you do a lot more things other than coding. And hence it's really a fun thing as I mentioned. And yes, the last thing, make games, just how you make projects. This is a picture of the Unity game engine. When you install it, here is the level, basically what the player sees. Here are your files. Here is what is there in each level, the list over there. For example, the chair will be in that list because it's an object. If you want to get another chair, you can duplicate it over there or maybe drag and drop a chair into that. It's going to be placed. Then you take your mouse inside and you can position the chair, etc. And that's how game development is done in regards to objects in games. This is the part, this is called an inspector console, where if you say you create a variable, CS students will know, you create a variable, you make it public, and then say it's a health. So the player's health is displayed here. So you don't have to go to the code, change the health of the player, and then compile it. You can just change it here only, temporarily, play the game, test how it is, keep increasing, and then finalize it in your code. So this helps in basically just like a framework. How framework helps you, this game engine helps you. You can run your code in normal compiler using VS Code or whatever, but this really reduces your time. Game developers, Omkar will know how that helps. Yeah, so what does the game engine do? It has inbuilt stuff like 2D or 3D graphics rendering. Your NVIDIA card, etc. needs to be inputted, right? What do you need to do? For example, it has shown that a car is red or that a car is made of metal. How is that done? The game engine, you tell the game engine, okay, this part is metal. So tell the NVIDIA card of your graphics card in your laptop, okay, this is metal, so it's going to display light in such a way that it looks like metal, even though we all know there's just ones and zeros in the code. So that's what is done by the game engine. Next is the physics engine. You don't have to manually enter how objects move at high speeds. The thing is done automatically by a game engine. If you don't use a game engine, you need to actually write Newton's laws of physics in the form of code that makes an object move as if it is real. For example, an object that's rolling on the floor has to have friction. There's inbuilt friction stuff that you can use in the game engine. But otherwise, you have to manually input the formulas of physics for friction, which you are doing with the normal code. And that is why game engine really reduces your time of development. It has artificial intelligence. How do zombies follow you in Call of Duty Zombies? How do they know where you are in real time as you move? You can't hardcode that, right? Because you keep moving. So all that is developed by the AI, which again will learn in third year or second year. Algorithms like path following, etc. We learn it in a second year, third year. So that's why pay attention in class. Next thing, AI function, what I mentioned, sound engine. That also you just have to import an MP3 file, maybe of the player jumping, like if you know in Minecraft, when the player jumps, it creates a sound. When the player falls, it takes fall damage. So you just import it, and what you do is you trigger it as soon as the person falls using some code. But if you are doing it normal without a game engine, you have to actually develop a sound engine using some long code, and it's not really worth it. Why do you do it when someone else has done it for you? And lastly, the animation engine, like a player is running, the player's legs have to move, which is not related to the velocity of the person, right? So that has to be done by the animation, which is a loop of the person's head moving front and back. So that's developed by the animation engine. You just trigger the animation and the player is moving. So yeah, the game dev, 2D games and 3D games. 2D games, what do you need to do if you want to do 2D games? 2D art, which can be done in Photoshop or even Paint application. You can even do it in Paint application and it's going to work as long as you know how to import it. 2D characters, your characters are obviously 2D, so you have to work with that. That also you can design your character in Photoshop, etc. And your levels are also 2D. So the advantage of going into 2D development as a beginner is you're working with only two axes, the x-axis and the y-axis. So the person is moving, it's only left and right, up and down, obviously jumping. But as a player, it's only moving left and right. Compared to a 3D game where you have to care about, maybe I can walk this side, I can walk this side. That's how the thing is done in basically for a 2D game. 3D game, the angle matters, you have to x-axis, y-axis, z-axis, a lot of things matter. So what are the popular game engines? There are only two, Unity and Unreal. Unity is used for Among Us, the most popular game in the pandemic. So you can see the art style of Among Us is really popular with a lot of other 2D games because it's done in Unity. Unity has a popular, similar art style that is used. So for that you need to use Unity. Unreal is another engine that's, right now it's very popular because there are a lot more features other than game development like virtual production, making short films, etc. So a lot of 3D games like Valorant, which is a multiplayer game, which is most popular, it is used in Unreal. All these engines are free. The only difference between Unity and Unreal majorly is Unreal is for advanced people who know a lot of coding, because you need to use C++ for that in such a way that's not the same way we use in our classes. And Unity, on the other hand, is C#. You use C#, which is another language, which is relatively simple to use compared to Unreal. Yeah, so game development, what about the cash money again? Freelanceable, no. No one's going to hire a freelance game developer unless you're really lucky. In India, very highly unlikely that you're going to get a job as a game developer. Most of the games that are played in India are games that are developed by companies that are outside. So in India, as of now, there's not really a market if you want to be a game developer. So you can do indie games though. Indie games are like freelancing, but you create your own games, you publish it, and if your game gets downloaded, you may earn some money from Play Store or from in-game purchases, etc. So it's not really popular as a game developer as a career in India in terms of jobs. But of course, abroad, there are a lot of companies. Jobs start from $73,000 to 59 lakhs, and it helps a lot if you're going abroad, if you're sure you're going abroad, etc. Like companies like Riot Games, Tencent, who develop the AAA games, etc. There are a lot of people who hire you, and they pay you a lot compared to Indian game developers. And the reason being that is there's not really a market. People who make games in India don't earn much because a lot of people are mobile game developers, mobile game players in India, like PUBG, etc. So that is why people who make mobile games have to be really good at what they do. and the time that you put into making a game may not necessarily give you the right output. And that is why it's better if you want to be a game developer to go abroad. So that's about game development. Any questions? Anything about it? Yeah.
What about Pokemon? How does it know here are the Pokemon?
Yeah, so this, in terms of game development or development in general, Pokemon Go has a lot to do with the front end part of development. Because it has to use your camera, right? If I'm not wrong, Pokemon Go. So it uses your camera to detect where you're looking. Then it uses the gyroscope sensor which is in your device to know which side you're rotating. Thirdly, it uses your location sensor to detect where you're moving. That data is sent to the backend. The backend is a list of servers of which Pokemons are there around your area. So as you move, it's going to detect, okay, this user is over here and there's a Pokemon 10 meters ahead in the backend map. So it's going to show you on your phone where the Pokemon is and going to render a Pokemon device, a Pokemon character on your phone. So basically, Pokemon Go is one of the few apps that has a lot to deal with front end. Because you need a lot of sensors from your mobile, etc. It also needs your network connection has to be good because it has to show render everything correctly, show the location, it shouldn't buffer, etc. So that is why, as I mentioned before, front end is the closest to the client. It has the best access to the camera, the location, and all the sensors in your device. That is why front end is mostly to deal with the client side. Yeah. Now back end. Backend is one thing that's common to all. Whether you're making web apps, whether you're making websites, whether you're making Android, iOS, or games, there will be some sort of backend that has to be implemented. Unless you're making a calculator app, which doesn't require backend. So what do you need to do for backend? In backend, there's no basic language. You directly start with the framework of your choice. After you do that, you learn DBMS and API, which DBMS we are going to learn in our third year. Okay. So DBMS means database management. And what you learn is basically how I mentioned about Netflix. You're going to show somewhere, right? The movies. You're going to show the user information somewhere. That comes on the back end under DBMS. APIs, as I mentioned before, the connection between front end and back end. The back end developer does it. So you learn how to implement DBMS. You learn how to implement APIs after your framework. Then you learn simple front end. For example, what if you just want to do back end? You don't want to deal with some sort of front end. So basically, you don't need to learn a framework, you don't need to specialize in front end, but you need to know the basic HTML, CSS, and JS. For example, you do backend, you create a software for a backend service that gives you the weather. How will you show it to a friend? You need to show it. You won't show it in command prompt, right? It's not appealing. How will you show it to a person who's hiring you? So what you do is you do HTML basics of HTML, CSS, JS. You create a simple bare bone website because you're not a front end developer. You connect it to your backend and show your data because your main focus is on the backend. So I would recommend learn basic front end even if you're a backend developer. And then you create projects just like the other. Choose a framework, learn internet protocols properly. This is important whether you're a front end or back end, not necessarily game development unless you're making an online game. Internet protocols are through which you'll be able to send data to and fro from the app to the backend, etc. For example, if you're making Netflix, you need to know how to send data, right? How you're going to receive information, etc. It's all over the internet through HTTP protocols and something called packets through which information is stored, etc. How to host backend? That also you need to learn. Like for example, as a developer, you need to host your to test it. You can either host it on your PC, so your laptop itself becomes a server, and then you test your code through that. Or you can host it online so that your friends can see it on a lot of free platforms like Heroku, which was free before, but now there's some issue with that. There's a website called Heroku. On that you can host your code for free, and you can do simple backend tasks on that. So that's in terms of how to host your backend. Develop good logic problem solving skills. As I mentioned before, backend has a lot to do with your logic and your problem solving skills because you need to optimize your code. You need to know, okay, so this guy is in India, there's a Bombay server, but he's in the north and there's a server in Delhi. So it's better if you connect him to the Delhi server. So you need to optimize your code, know which is the closest. It involves a lot of problem solving skills, etc. So make sure you're good at logic solving skills. You can of course learn it as you get into backend, but know that you will be using a lot of logic development skills when you're doing backend. Work with the console. we already, second year students, we already started working with the console in terms of writing programs like GCC, G++, etc. when we run the programs and compile. In terms of backend, at the beginning, of course, you won't do your front end for your hosting your back to show your backend at the beginning, right? You'll first write your backend and then to show other people you're going to use the front end, right? So at the beginning, your code will be executed on your console only. For example, is the function working? You can put a, how we have a C system to print line, serial print line. You have that in your console, it's going to display, okay, the function is working. So you know, okay, this part of my code is working. Unlike front end where you can actually see, okay, you make a box red. You can actually see the box that's red in color. So you don't necessarily need a console as a front end developer. Yeah, learn basic web dev, which I mentioned before. What are the frameworks? Yeah, when I say Django, it's not the movie Django. It's just Django, which is a framework in Python, and Dropbox and Reddit uses it for their backend servers. Of course, their front end can be React or whatever. Again, Netflix has come back again, like another cameo by Netflix. It uses Node.js, which is a framework in JavaScript, and it used to be popular. It is still popular, but now Django is also coming up. A lot of people are getting into Django. So people who already know JavaScript or are doing front end and want to do back end, for doing React.js, for example, you already know JavaScript, right? So why would you go into Python and learn separate thing? If you know JS, do Node.js. So you know one language, you can do multiple things. People who have already done Python, CBSE people, I think they have portion 11 and 12th of Python, if I'm not wrong. For them, Django is fine because they know Python, the basis of Python, and Django is written in Python. So yeah, EB and Netflix uses Node.js, Dropbox, Reddit uses Django. Full stack development, another technical jargon that's you probably heard. What is full stack development? Full stack technology refers to the entire depth of a computer system, yada. It's front end and back end basically. Front end plus back end is equal to full stack. If you know front end as well as back end, you're technically a full stack developer. In the yesteryears, it was fine if you just do front end, if you just do back end, people would hire you. But if you go to any listing of development now, they either ask for a full stack or it's something totally entirely different. Because it's really, they have to hire just one person to do the work of two people basically. So it's really helpful if you know both, and I would recommend taking up first one at a time. You do front end first and then get into back end or whatever, whichever direction you want to move in, depends on your liking. It doesn't necessarily mean that you have to know both things properly, but they require that because you need to, suppose you're a front end developer and there's a back end developer on your team. You have no idea what is talking for the company meeting. That is why it is highly recommended that you know it. You're most likely to get hired and get jobs basically if you know full stack development. Stacks. So this is not the stacks that we do for DSA. A stack is a collection of languages or frameworks that are used together, and if you know all this together, you can say you're a full stack developer in this stack. So here it's called a mean stack, which is short form. MongoDB is again database management system. You do your database in that. Express.js and Node.js comes under backend. Of course, AngularJS I mentioned before. It's front end. So if you know this entire stack, that's MongoDB, Express.js, AngularJS, and Node.js, which is a lot of JS. It's a mean. It's called mean. So if you say, okay, you tell someone, oh, I'm a mean stack developer, that person will know that you know all these 4 frameworks, and you can do a full stack application using these 4. Mern is the same thing as mean, except Angular is replaced by React. And Mern was the most popular a few years back, until like Angular is coming a bit up now. And Mern sounds better than mean because why would you want to be mean? Last is lamp, which is Linux, Apache, MySQL, and PHP. So in terms of the OS on which the server runs, you can either run, most servers run on Linux, but you can also run it on Windows, but Linux is more optimized for server-side code. So in terms of that, Linux, if you're using Linux on your server, then it's called LAMP. But some people also use Windows and they just call it WAMP, which is just a W instead of N. Last thing is what I use, Flutterfire. This is a new thing that's come. It's Firebase that is used for backend. It's not that advanced as Node.js. It's made for beginner simple projects. It's developed by Google. Flutter is also, as I mentioned, developed by Google. So the combination of both two, since they're developed by Google, they have a good integration, and you can create good amounts of applications using Flutter and Firebase. So this is a relatively new one. You won't find any, not many people hiring for this framework, for this stack, but the top 3, of course, especially the top 2. Okay, so that was on full stack development. Any questions on full stack? Anyone? FEs? Yeah.
How much time to become a full stack developer?
So basically, for you need to think of it as front end separately and back end separately, I would say. So your front end, as I mentioned, it depends on how fast you are, how much time you're giving. So suppose you give 20 minutes a day, I would say 2 months you can easily become a full front end developer. Back end would take relatively more time because I told you it has a lot of logic related stuff, so it's going to take a little bit longer. But if you're passionate enough, in 6 months you can be a beginner full stack developer. Provided you're giving time every day, etc., you're practicing, you're creating projects, you know how to, you're not just watching videos, okay, I know this. As soon as you watch a video, you implement it, etc., and then you'll be able to do it in 6 months. That's my opinion, basically. But again, it depends on how fast you're grasping. It can be shorter or longer.
Azvern, anything in this combination that uses Django and Python or something?
In the popular stacks, right, as I mentioned, Django is relatively newer compared to Node and JS frameworks. So in these stacks, there's no Django. But then there are stacks that I haven't included in this, but they use Django. And mostly there are not many like developers who use Django as a stack. There's no proper stack because Django has a lot of things like it has inbuilt database management and stuff like that. If I'm not wrong. Yeah. So Django has inbuilt database management. You don't need to know MongoDB separately. That is why Django is like one whole thing in one. That's why there's no proper stack because it just Django, you know the entire backend, and then you can do your front end framework. Version control. This is Git and GitHub. Everyone has heard of GitHub, but half of us don't know what GitHub is. It's a technical term. So basically, what is version control? It's a class of systems responsible for managing changes to computer programs, documents, large websites, etc. Basically, so what is version control? Basically, it's a software that helps you keep a track, like a log of whatever code you do. For example, you are developing an app. You first do the app bar properly, you implement it, etc. And then you write a code, right? And then you save it somewhere. Then you create another thing. You create the app bar. But over that period, if you realize, okay, wait, something went wrong somewhere. How will you check? You have done everything, right? It's compiled and all. So what you can do is you go back to you have a history of whatever codes you have done. Like basically like a time machine. You can go back to the previous versions of your software. That is why it's called version control, because you can control the version of your software. Another thing, what is GitHub? GitHub is a website where it's basically like cloud, but for software. You can upload your code there using version control and it gets saved on your profile. So you can access all your code, etc. So if your PC crashes or anything, it's there on your cloud. And you can access everything online without needing to open your laptop, run the code, etc. And people can download your code from GitHub itself. You can effortlessly work as a team. So why is this very important? This is very important if you're working as a team for your final year project, or maybe you're working for a company and you need to collab with other people. Will you take your pen drive, copy the code, go to your friend's house 13 kilometers away, put it in his PC, then run it, then allow him to make changes, go back home and then do it again, rinse and repeat? That's not ideal, right? So what you do is you use something like GitHub, where you give access to your project to other people to change, and then they will suggest some changes. If you feel that the team developer, so for example, you do the app bar and the other person is doing the side drawer. You finish the app bar, you upload on your GitHub. That person will get the changes automatically on his PC also. So he downloads the latest version of your software from GitHub. He makes his changes, he again uploads to GitHub. You download again and then it keeps repeating basically. So it effortlessly works as a team. Have a record of all changes to your project. As I mentioned, whenever you make a change on GitHub with your project, it creates something called a commit, which tomorrow will be spoken by Grishma, so I won't speak much about that. So basically, it has a record of all your projects, of all the changes to your things, so you can revert back to a time when your project was not working, if your project stops working. Code portfolio. Basically, a portfolio is a place where you have all your projects together. In normal terms, it can be a website. For example, if you're a management person, all the things that you have managed will come on your website, and that's called a portfolio. In terms of code portfolio, GitHub has all your code listed in one place. So if someone wants to check, okay, this person has done the project in this person has done the project in this. So it helps with that. Yeah, so this had audio, but there's no speaker here. This is a game development project that I was working on for 6 months, and there's a reason I'm showing you all the video. I'll tell you at the end. But these are clips from the game that I've recorded. It was a platformer game, somewhat like Super Mario kind of. It had the 2D art style. This is in Unity, by the way, if you can recognize the engine from that. Yeah, so why did I show all that? I worked on this project for more than 6 months, bunking my 12th standard classes, online classes, and working on it because I was ready to launch it on Play Store. It had a story, it had the UI, it had everything from the start to the end, including the levels. Just some minor changes were left, and that time I wasn't aware of GitHub, etc. Okay, and I worked on this project for more than 6 months. I told you, I kept it as a surprise. I was supposed to launch it on a grand scale, including weblogs, etc. My hard drive crashed. The game is gone. I have no access to this file. These are the only clips I have on the game. I was sending it to a friend. So why I'm showing you this video, the importance of GitHub. If I connected my Git and my GitHub to this project, I still would have had the game regardless of my hard drive crashing. You can replace your hard drive, but I can't replace my game. So that's the importance of Git and GitHub. Please use Git and GitHub if you're starting coding, regardless whether it's school projects or whatever. Use Git and GitHub, or you'll have to cry over a hard drive. I went all across Goa trying to fix it, but they couldn't fix it. Okay, now projects. Someone had asked me here, right, how to. So what are the projects you would need to practice, at least develop one so that you have an idea of how good you are. In terms of web app dev, make a website, HTML, CSS, JS with a calculator. A to-do list site. So basically, your morning tasks, you can have a website that has this. Then the shopping site will come under frameworks because you need to use something like React, etc. Maybe have someone do your backend for you, or you can just have a mock site that does not have a card, which is what most people do at the beginning. Make a quiz game. This will test your logic skills, because what we do on the console for our classes for C and C++, you might be able to use that logic and then use it and make an interactive UI based thing using web app. A mock social platform like Instagram, Facebook, etc. This will test how good you are at integrating your backend, because you have to send messages, you have to receive messages on time. You need to show the status, the Instagram photos, whatever. So this would be like your final project that, in terms of beginners, okay, that will test how good you are at integrating the entire form of web app dev. App dev, same thing, calculator app, a to-do app, a shopping app. WhatsApp clone, this is different from a mock social platform because it's more heavily based on sending data in the form of text. It has a lot to do with user accounts, because what messages shouldn't be overlapped. For example, if I'm sending a message at 4:20, the same person is sending a message to me at 4:20. What will happen? Which message will get displayed first? A lot of things you need to consider. You need to learn how internet works basically when you're doing this. And of course, mock social platform is the same as web dev. Game dev is something different from this. 2D platformer, just how I showed you the clips before. Something like Super Mario. You don't have to worry about the looks. Even the triangle that's jumping and collecting circular coins is fine. No need for graphics. As long as there's a logic of a person moving or jumping. Endless runner, something like Temple Run or Subway Surfers. This is much easier than a story game because you're just looping over something in terms of code. There is no actual endless runner, you'll probably guess that. It's a loop of code that's being displayed, so you don't run out of memory. RPG is like something like if you played the Nintendo, GBA, Pokemon games. It's a story based where you move, you collect things, you do tasks, etc. Then you get into 3D. After you do all these projects, you're thorough with this, you get into 3D games. Something like a basic Call of Duty game in 3D FPS. That can be done in Unreal or Unity if you want to, but I would suggest Unreal because it's made for this basically. And lastly, open world. Something like Minecraft where the world doesn't end, you keep moving ahead. It creates terrain on its own. But then you would say, how does it do it when there's only 8 GB RAM and I'm keep moving? As soon as you move in front, the place behind you gets deleted in memory. So you do not know that unless you turn back and you see. That is how games handle open worlds on your PCs. So these are the list of the projects. We will share the PPT later, but this is what you need to know if you want to be used. Is there a question on this? Yes. The fun part of any software developer. Hackathons. Hackathons are a day long, sometimes 48 hours, depends on the organizers, where software programmers, developers, designers come together to build and design something. In short, what you do is, whatever you are doing, for example, the calculator app or something like that, you are supposed to do it in just 24 hours, but that something is not what you want. It's told by the organizers and it's not already existing in the world. So you have to come up with something new in 24 hours, solve the problem that they give you, implement it, and make an app or a website. So what does this test you with? Why are hackathons important? The why, the when, and the where. The why. It tests your developing skills under a time limit. A calculator app can be done in 3 months or 6 months. You can take your own time, etc. And you can even Google it, etc. You have time to read, watch videos, how does the logic work, how to implement a button, etc. But if you're given 24 hours, you do not have the luxury for that. And that is where you're tested on your skills of a developer. You're tested how good you are, how fast can you be. Do you know those things at the flow of your hand, or do you have to Google everything that you do? So it puts you in a place where you know how good you are at what you do. That is why hackathons are good. Problem statements are new. You're forced to be creative and think. It develops your logic. You're supposed to come up with things instead of just, oh, this person told me to make a Facebook clone, so I'm going to just copy what Facebook does and do it. You have to come up with solutions that are new and that test your skills. Work around for long procedures. Suppose you are doing an Instagram app where regarding the chat system. You have a chat system that works, but it takes you like 2 days to implement, to write in code. You can't do that for a hackathon. And neither can you do it if you're working for a corporate business, because if your code for just messages takes 2 days to implement, that means your code is not fast enough, your code is not optimized. Hence, hackathons make you get your code optimized, it makes you develop faster code, it makes you get better at coding basically. Teamwork, this is the main thing. As software engineers or software developers or engineers in general, communication and teamwork are the main things in terms of engineering or software development. Because you're working as a team in a hackathon and you have only 24 hours, you can't send a message, "Arey, message soil na re," you can't say that. You have to tell the person on the spot, okay, I want this thing implemented now, I need to test it on my front end. Okay, it's not working, how do we go about it? What else can we do instead of this? You need to implement all this stuff in the terms of just 24 hours or 48 hours. You have to tell, okay, for our hackathon, which is conducted by the computer department last year, techniques, we had to work together as a team of 3 developers. And one of us, we all were sleepy, right? So what we did was we took turns. So just how the night vigils go on, one person would sleep, then we would wake him up after 2 hours, then he would continue, then the next person would sleep. This is how we managed for our hackathons. Realizing your shortcomings. As I mentioned before, you realize how bad your code is. You realize, okay, wait, I thought I knew how to do this, but then you realize you don't know how to do it without Googling too fast or do it in just a short time. So it basically helps you in regards to your shortcomings. Networking, the best side effect I would say of hackathons, this is not intended. You meet a lot of new people for hackathons, you meet people from all across the state, or if you're having it online, all across the world maybe. So hackathons are good for networking. You learn new things because people say, okay, we are using this technology, I can do the same thing but better using this technology. So hackathons help you with regards to networking, and that is why it's really important. When and where? This is a website, I won't open now because there's no internet, but hackathons, you can get online hackathons on this website called Hacker Earth. It's also used for competitive programming if people know. And so basically these are a list of online hackathons. Once you're good enough, you can take part in this. There's another website called DevPost, same like Hacker Earth, where it gives you a list of hackathons. Goa colleges mostly have their hackathons in October. Maybe it's because of Hacktoberfest, but yeah, PCC and Don Bosco's have their hackathons in the October-November area, and every year because they're annual event. GEC Technics, the Cursor Council, they have theirs every year, and it was held a few months back. So this are in terms of Goa, what happens. And the hackathons are mostly on weekends because it's a Saturday, Sunday, so you don't have to go miss classes for hackathons. Yeah, do I do the entire thing or how do I get partners? This is the main question. You don't have to do the entire thing and you are not recommended to do, otherwise it's not a hackathon. A hackathon has to involve a team because it's a team activity and so it is a team activity, right? So you need to get to know people. If you're doing front end, go find a back end person. If you're doing back end, go find a front end person. Collab with them, connect with them. Do practice projects at home. Regardless of whether you're doing a hackathon, collab with them, work with them at home. Then you can go for a hackathon as a team. And that is how I would say you do hackathons as a team. How do I get partners? By communicating. That's the main thing I told you. The advantage of this is you're forced to go and meet new people, interact. And that is the key point in terms of engineering. Because you need to go and talk to people, get to know new people, get your LinkedIn right, go talk to seniors, talk to people in your own class, maybe even encourage them to learn new things, and then you can get a partner. Yeah. So that was about hackathons, and this is the end of. I have a few more slides, but it's not regarding the content of today's talk. So this was the talk on software development and the roadmap. If you all have any questions or feedback, good or bad, feel free to ask. Anyone?
Feel free to ask.
Yeah, feel free to ask questions, however, regardless of how stupid they may feel. No questions are stupid here.
Excuse me, how was your hackathon experience? Like, did you manage to complete?
Yeah, so for my hackathon, we were given 16 questions. So that you're given a PDF, okay, at the starting in the WhatsApp group of 16 questions, which do not have a solution necessarily. And then you are supposed to decide which topic you want at the fastest because someone else may take your topic. You send it to them and your topic is finalized. And then you go to the event hall and you start. So I was the front-end developer, I did mobile applications and I did in Flutter. The backend was is Atharva here, Atharva from third year. No. So he did the backend in Django, and then there was another finalist student who did the ML part, machine learning part, because we had to involve a little bit of machine learning because of the question that we chose. And together the question that we got was using the data from devices like your Fitbit, etc. You get the data like the heart rate, the weight of the person, etc. You create a user profile based on the health. And then, depending on how healthy the person is, you recommend the cheapest life insurance policy to that person on his app. So suppose the person is slightly obese or he has cholesterol in his blood. You know that you have to recommend a life insurance policy that has cholesterol or heart diseases related to that. So how did we implement that? I was just a front-end person, so I made the app that basically uses Bluetooth, it uses Wi-Fi to connect to the Fitbit, etc. and take in data from there. I take all that data, I also take user input like the age, because that time we got from the Fitbit, right? You take all that and then I send it to the backend server. The backend server then takes that data, combines it with the machine learning algorithm which is there, and it takes another list of insurance policies and then recommends the cheapest one. That data is then sent back to me in the front end and then it's displayed on the list of the user. So this was done in 24 hackathon. After we coded, we had to make a PowerPoint presentation on it and explain what are the technologies we use, why it is necessary to use so and so, what are the future implementation, because we could do it only 24 hours. So if we were given more time, what could we do, etc. And that bagged us the first place for Technics last year. Our team won the first place for Technics hackathon. So that's how normally a hackathon goes. And it doesn't mean everyone at the hackathon was like not telling each other what they were doing. We played Uno at night, at 2 a.m. in the night because we were feeling sleepy. We drank at least 13 cups of coffee to stay awake. It was really a fun experience regardless of the technical aspect. We even tried to sing and dance so that we get some kind of energy. And we also went to other people, some people from the other teams had some questions regarding because they couldn't solve something. We sat with them. It was a fun-filled activity that was not necessarily competitive. in terms of techniques and in terms of hackathons at the lower level, basically. So you should not see this as a competition, but rather as a learning experience, and that is why I recommend hackathons to every software developer or engineer.
What are the resources for front-end development?
Yeah, I have linked some in the presentation. I'll send a PPT on the groups later, but for front end, there's a playlist. I would recommend Apna College, if you all know, it's a nice channel. There's a nice channel on there's a nice playlist on HTML, CSS, JS. You do that. For other applications, I'll send you all the playlist also on the group. But yeah, for web app, I would say do that. And then there's another playlist for React.js, which I would send you all also on the group later. But so yeah, you do the playlist of HTML, CSS, JS thoroughly, properly, and then you go to app or whatever. I mean, go to your frameworks.
Azvern, during your journey of learning coding, you might have faced several pitfalls, right? So would you highlight them for the new developers that want to be?
Okay. So this is not something I wanted to say, but I'll tell you what the one grave mistake, not grave, but mistake I feel y'all shouldn't do it, which I kept mentioning indirectly to y'all. I directly skipped to Flutter framework without doing Java. And I had a lot of issues regarding the low level stuff, regarding implementation of sensors, etc. Of course, you can do it in Flutter by copying code, but it's not necessary that you're going to understand how that works internally, or if you want to take maybe a part of that, unless someone has already done that for you. And that is why I say, learn your basics first and then jump to a framework, or else it's going to be a real issue when you go backwards. People who have done Python first and gone to C++ later also have the same issue. It follows the same process. CBSE students over here must be knowing that. It's a real headache because you do the easy stuff first, which is directly implemented by the framework. You don't know how it works, and then when you need to go back, you're lost because you never tried implementing it in the first place. My first thing is learn your basics, C++, then the basics of it, whichever direction you're going in, and then go for a framework. Secondly, I thought that I did Java first when I was in my 9th grade. And when I say I did Java, it meant that I just watched videos. I wrote basic programs and that's it, following the videos. I never developed any application, but I should tell people, okay, I know Java. And people just think I'm good at coding. Then came 11th standard when we started classes. Your CS students know. We started problem solving like array handling, etc. Or not just learning a language, but how to implement it in problem solving. And that is when I realized what CS actually means. So I would say, once you're learning a new language, directly start implementing it. Watching your videos and knowing something is way different compared to when you implement it. The real learning happens when you actually type the code and you try to change things. For example, if there's a line of code in React.js that makes a box red, can you make a box blue with the same thing, or do you know how to just make it red? You should know that, right? And that thing can only happen when you copy the line, you put it over there, you actually change and see, okay, if I change this parameter, the box becomes bigger. If I change this, the box becomes smaller, the box becomes rounded, etc. So this is a thing that will only be done once you start actually trying out stuff and actually implement stuff. Any other questions? By the time this loads, any other question? Can be developer related or engineering related also in general, specific to web app, anything. Yeah, anyone?
What system do you use for game development?
System as in the game engine?
No, the hardware.
Okay, so for game development, it's slightly more than much more than web dev. Because in web dev, you can even have a small, tiny S computer and it's going to work. But in terms of game development, in Unity, when you're doing 2D games, you can have even 4 GB RAM, it will work at a low quality. And a processor at least higher than i5 in terms of Intel. I'm not sure how AMD works, that's it. And a graphics card, a basics one. Even in Intel AC, the inbuilt ones work fine enough. There are better engines which are made for lower optimized games like, Umkar, what is? Godot. He has done game development in an engine which is not Unity. It's a simpler one, but it's not that popular and it does not have that many resources. But if you want to get into game development and you have a bad PC or a slow PC, you can use his engine, which is good. Yeah, so this question is very common. I should have mentioned it actually. So if you're a person who likes their stuff to be seen by other people, go for front end. If you're a person who likes to be behind the scenes but gets everything working perfectly, or if you like to be the person who's behind the scenes and whose work is not being seen basically, like the director or the producer, then go for backend. If you're good at logic skills, go for backend. If you're good at design, you're good at being creative, you're good at, for example, a button that is floating is always better than a static button, right? So for that, you go for front end. If you're good at designing, you like different designs, you like changing things, you like making things look perfect, go for front end. If you're more of a logic behind the scenes person, go for back end. Yeah, any other questions? Anywhere else? Anyone else? Okay. So before we end the session, are there any people here who are not in the WhatsApp groups of the Coders Club? Anyone? All here are Coders Club? Okay, because I have the QR code shown. So this is my QR code. If you all want to scan it, you all can, but it has all my information like my LinkedIn, my GitHub, my Instagram where I post my coding stuff. And yeah, that's it. Also my Gmail if you all want to contact me. Please, yeah, scan it. Any more questions as they scan the QR code? I will send the PPT later if you all are having trouble scanning the QR code. Okay. This is the QR code for the groups. This is the FE code, the SE. Again, I will share the PPT later, so if some have not ordered, I'll send the QR code later. Yeah, I'll end with a quote by every software developer. If it works, don't touch it. If your code works, it's giving the right output, don't bother the why and the what. It's working. At the end of the day, this is what matters. Yeah.
Just wanted to ask, what do you feel is what inspires you to create your web apps? What inspires you to code?
Okay, so what inspires me to code? That's a nice question. So basically, I like logic development related stuff. I also like putting stuff out there and problem solving. More than solving in terms of logic, I like solving a problem. If there's no solution that exists, you create the solution yourself. That is why we are here, right? As engineers, to solve problems that are there, but there are no solutions that exist. So if I'm doing something and I realize, okay, there's no app for this, I can go home, code it, and I can create a bash script for that. I can run it and do it. For example, one of my friends, they have a gym and they didn't have a proper system of entering the data. So someone used to make Excel sheets and the person left and it was really unformatted. So I just wrote a JavaScript code that does it automatically and gives it a nice tabular format and then sends it to an Excel file. So the good thing about being a software developer and engineer is you can create a solution for virtually any problem on the spot in less than 5 minutes if the problem is small. And it doesn't need to look good, right? If you're making something just for yourself, it doesn't necessarily have to be good. So that's a good thing about developing softwares. You can just code anywhere, solve your own problems, solve the world's problems, and that's why we are here. That's what I would say. Any other questions?
What knowledge should we have if we want to learn Flutter?
For Flutter is a framework that is in a language developed by Google called Dart. So for that, if you know JavaScript, Dart follows a similar fashion. So I would recommend do JavaScript first, do another framework before Flutter. And if you want to search for jobs now, as Flutter, since it's new, it's not that popular. But if you want to get into Flutter, it's really easy to implement, better than React Native to implement. The inbuilt stuff is really good for designing and stuff. The main feature of Flutter was to have good designs and UI implementation. And that is why I would say Flutter is really good in terms of that. So if you want to do that, you don't need to learn Dart. Flutter is enough because the things that you learn in Dart are there in Flutter. As long as you know how to use JavaScript, because a lot of functionality of JavaScript is in Dart. So as long as you know that, you're good to go with Flutter. And you can even run Flutter Android apps in VS Code. One more thing I didn't mention about Flutter because I thought it would be outside the scope. Flutter is a cross-platform language or framework because you can run one code and the same code can be reused to make iOS apps as well as web apps as well as Windows applications, as well as Linux applications, as well as Mac applications. So it's one code that if it gets popular in the future, people can use, companies can hire just one team that will change minor things depending on the platform there. But as of now, Flutter is slightly slower. It takes a little bit more RAM. It takes way longer to load on websites. So I would say for now, just stick, if you want to code for Flutter, stick to mobile applications because it's made mainly for that. Any other questions? Anything? Yeah, so I would like to end the session by thanking the Coders Club for allowing me to speak today. Thank you, Malshka ma'am, for giving permission as the faculty advisor of the Coders Club. And also thank all of you for coming, even though we expected less people, but you have filled up the entire thing and people had to be shifted. So yeah, thank you everyone. And now Grishma will speak regarding session 2, which is tomorrow, which is online and the workshop.
That was actually a very good session. So tomorrow we're going to conduct a session on open source and Hacktoberfest. So there are some prerequisites. They're not prerequisites, but some things that you all have to install. We kept it online because it is more hands-on. I'll be showing you some things, how to use GitHub and Git especially. And I'll talk about Hacktoberfest. It's a program which is to support and practice open source throughout the month of October. So I'll be sending some links on the group. I hope you're all on the group, Coders Club group. If not, we'll try to forward them through the class groups and you can forward it to your friends. And you'll have to install Git, which is, let me just show it here. Yeah. So this is version control system, but for your local system. So when you want to save code on your laptop, you can't always put it on internet, right? When you're developing in your laptop, and you cannot always be connected to the internet. So in the local system, version control is done using Git, and I want you to create your account on github.com. Let me just. Over here, you can create your account using your mail ID, and we'll show how to use it tomorrow. So that is pretty much it. I'll send the links related to it on the group. So we can wrap up the session there. Yeah, it's at 4 o'clock tomorrow. We'll be sending the meet link on the group. So make sure you join the Coders Club group. Okay. Thank you.
Any other questions before we can end the session for today? No, right? So thank you everyone for coming. This was the first session in a long time of the Coders Club. Thanks for attending. We'll have more things later on. Thank you.